Hi everyone, welcome to George MathWorks. Today we are going to be looking at a cubic polynomial example. In the last video, we did another example where they had given us a graph and we were to extract an equation from there. The question here reads that a cubic function has the following essential properties. F of 0 is equals to 8, f of 4 is equals to f of 1, which is equals to f of 0, f prime of 3, which is the first derivative evaluated when x is 3, is the same as the first derivative when x is 1, which is equals to 0. F of 3, which is a function evaluated by when x is equals to 3, is given as 8. Now, from this, before we even cover most of the questions, let me read the first one though. Sketch the graph of f, clearly indicating the turning points and the points of intersection of the graph with this axis. From this, we are having important words here, clearly indicating turning points. We should know how to find turning points, clearly indicating also the intersections with the x-axis. We need to know what all of this really means. Now, we are discussing a cubic polynomial. When someone mentions a cubic polynomial, we should remember this. In general, a cubic polynomial looks like this. F of x is equals to ax cubed plus bx squared plus cx plus d. This is a cubic polynomial in general. Now, this question tests whether we fully understand the pieces that are here. F of 0 is equals to 8. Now, this simply means that we are discussing a function f of x. Wherever there is x, if we put 0, we are going to get 8. And this reminds me of what is called, what we learn in class when they say Y-intercept. Y-intercept is the point where the graph will cut the y-axis. And at this point, x is equals to 0. So in this case, if f of 0 is equals to 8, if f of 0 is equals to 8, it means that our y-intercept is equals to 8. So there is a graph by my side here because this question says sketch the graph of f, clearly indicating the turning point. So I am going already straight to the graph and I'm going to mark this point f of 0, 8. We said it is the y-intercept, which means this is the point where the graph will cut the y-axis. Now, if this is the point where the graph will cut the y-axis, I'm going to mark the point here at 8. We have the point. When x is 0 here, when x is equals to 0, my y is equals to 8. That's the meaning of what we are looking at there. Then at this point, we also have f of 4 is equals to f of 1, which is equals to 0. Now at this point, they are telling us that when x is equals to 4, if x is equals to 4, y is equals to 0. And also, if x is equals to 1, y is equals to 0. That's the meaning of this point here. That's what it means. If we evaluate a function and we get a 0, in other words, they say x equals to 4 is a root and x equals to 1 is a root. Or some will say from this one, x minus 4 is a factor. That's what they would say. And also here, x minus 1 is a factor. That's what we cover in class. So here, with this discussed like that, it means here, these are the points where the graph will cut the x-axis. When y is 0, this means x-intercept. So I am going to mark the point f of 4 when x is equals to 4 and x is equals to 1 on my graph paper. So let's take it to the graph paper. I have the point here. When x is equals to 1, we mark that point. Then when x is equals to 4, we mark that point. These are the points where the graph will cut the x-axis, as we have seen. Then we go back again to the information. It reads here that f prime of 3 is the same as, or the first derivative when x is 3 is the same as the first derivative when x is equals to 1, and this is equals to 0. Now, when we discuss the first derivative, let me take this one to the side. If f prime of x is equals to 0, this will give us a turning point. So for a turning point, the first derivative is equals to 0. That's what we learned. So if the first derivative at when x is equals to 3, when x is equals to 3 is 0, it means that this one is also a turning point. And also this one, when x is equals to 1, is also a turning point. Now, if these are turning points, and we already saw that x equals to 1 is the point where the graph is cutting or touching the x-axis from this part, and it is becoming a turning point. It means at this point here, the graph, we now know that it is going to turn when x is equals to 1. That's the meaning of this. It is a turning point because the first derivative at x equals to 1 is equals to 0. This makes this one a turning point. Also, x equals to 3, it is going to be a turning point. So I'm going to mark these points. We already have them. We already have one as the x-intercept. So here, I know that my graph is going to turn at this point here. We already have the point. When x is equals to 3, I am going to have a turning point, but the graph is not going to turn here when x is equals to 3. So they gave us something here. They later said that the function, when it is evaluated when x is equals to 3, it gives us 8. Remember, we agreed that, or from this point we say, when x is equals to 3, we have a turning point. We just not know yet where it will be on the y-axis. But they are saying here now, when x is equals to 3, if you take that x equals to 3, which is a turning point, you will find the y value to be 8. So we are saying we are going to have a turning point when x is equals to 3, and at that point, y will be equals to 8. So I'm going to mark that point here. When x is 3, when x is equals to 3, y is equals to 8. That's where I have another turning point. So now, at this point, I can say we have exhausted all the data points that are given, all the information, we have used it. We have the y-intercept, we have the x-intercept, we have the turning points, we have the y-coordinate when at a turning point. Here, we also have the turning point with the y value at a turning point being 0, because this is a turning point. Now, what is left is to join these points and come up with a cubic polynomial, because the question we are answering says that sketch the graph of f. It says sketch the graph of f indicating the turning points and the points of intersection of the graph with the axis. The graph intersects with the y-axis and also the x-axis. So I'm going to be joining those points here. I'm going to join the points. Let me do it this way. Right. So the graph is going to start from, it cuts the y-axis at 8. So there we go. Cuts the y-axis there. Sorry about the size of the pen. Then it turns at this point. It also goes up. It has a turning point there. Then it comes down. It cuts the y-axis at 4 there. So that is the graph. I'm sorry about the size of the pen, but you saw the picture. The graph is cutting the y-axis at 8. It turns at 1. It has a turning point, and it also has a turning point when x is 3 and y is equals to 8. And it also cuts the x-axis when x is equals to 4. So this question is answered. Now we move to the next one. The graph is set. We move to the next one. The next graph says that show that the defining equation of f is f of x is equals to minus 2x cubed plus 12x squared minus 18x plus 8. When a question says show that, this means what we are given here is the answer. We need to arrive at this point. But where are we starting? We are starting from the given information and together with the combination of the graph. And that's exactly what I'm going to be doing here. If we have a repeated point, this one is a repeated turning point. We have a repeated point here. That's why the graph is turning at x is equals to 1. So it's a repeated point. Now I am going to write f of x. Sorry about this. Let me write it this way. Let us have f of x at this point. F of x to be written as a. Now, if we have, in general, the graph will be cutting at different points the x-axis. Like this. This is how the graph will be like. It will be cutting at the x-axis. Since it's a cubic polynomial, we expect the graph in general to be cutting the x-axis 3 times. We expect it to have 3 x-intercepts. Now, at this point, it has a repeated value here. So for a repeated value, if we are to say here, if we are to simplify this, since we have a repeated root here, it means that wherever there is, okay, we are going to simplify this further to say, I have a constant, then I have here at this point x minus 1, but it is repeating, so I will also have this part as x minus 1, then here, close bracket. Then the value here is x is equals to 4, which means that, because this part is x is equals to 1, and this one is x is equals to 4. So here, we are going to get x minus 4. Now, with this one done, what we need now is to expand this equation. So we are going to say a at this point, this is the same as x minus 1 squared, then multiplied by x minus 4. Now I can expand this to say a here. I can start by writing x minus 4. I'll tell you why I did this. Then x minus 1 squared. We need to understand that multiplication is commutative, which means that a times b is the same as b multiplied by a. Now, at this point, the reason why I started by this, I want to expand this one which has a squared already. So it's x minus 4 here. If we expand this, we will get x squared, that's x times x, then minus x plus 1. If you are not familiar with expansion, you need to familiarize with that. Learn how to expand. Then here I have a. This is x minus 4. It will be multiplied to, I'm now simplifying inside, minus 2x, then plus 1. So I am going to multiply everything inside by x here. So that's x squared, x cubed. Okay, we can actually simplify this at this point. We are now given also a point there. They gave us another point. They said that when x is 3, or we can use this one, if x is 0, my value of y is equals to 8. So I can use this point here to find the value of a before I go further with the expansion there. I can even find a at this point. Now, we are given that. We are given this point here. When x is 0, y is equals to 8. So with this point here, wherever there is y, this is my y. We need to understand that y is the same as f of x. It's notation. So wherever there is y, I'm going to put 8 is equals to a here. Wherever there is x, I put 0. That's 0 minus 4. Then here, that's 0 squared minus 2 by 0. Then here, plus 1. Plus 1 like that. Then in the end, I have 8 is equals to 0. I have a 0 minus 4, that's minus 4. And at this point, that's 0 here, minus 0, then plus 1. So if we multiply this in the end, we have 8 is equals to negative 4a. Divided by minus 4, divided by minus 4. So in the end, therefore, a is equals to minus 2. Now, continuing now with what we are given, we still want to show. So it means therefore, means that f of x, it therefore means that, therefore, the f of x we want to find is equals to, wherever there is a, it's minus 2. I'm now substituting here so that I continue with my expansion. It's minus 2, open bracket. Then here it is x minus 4. Then here we were on x squared minus 2x plus 1, like this. So I can, since I'm expanding, I can multiply here everything by minus 2. So if I do so, I will get minus 2x, then plus 8. Then everything will be multiplied with x squared minus 2x plus 1. So this is equals to, now I'm expanding this, everything in this bracket will multiply everything in this bracket. To those who do not understand, you can do it this way. you can have minus 2x. You can have minus 2x here, multiplying everything there, x squared minus 2x plus 1. Then you have this plus 8, also multiplying everything inside. To those who do not know the shortcut of expansion, you can follow it this way. So if I multiply here, I'll get minus 2x cubed, then plus 4x squared minus 2x plus, I'm on this one, 8x squared minus 16x plus 8. Now simplifying further, this one is coming out as it is, minus 2x cubed, then 4x squared, I have 4x squared plus 8x squared, that's plus 12x squared there. I have plus 12x squared. Then I also have this part here. I also have minus 2, which is this one, minus 2 minus 16 to give me minus 18x. Then in the end, plus 8. Now we need to check at this point. This is what we have found as our f of x. We want to see if we've arrived at what they wanted us to show. So I'm going to take you to the question and we compare our answers. So here they wanted us to show that minus 2x cubed plus 12x squared minus 18x plus 8. Excuse me. Now, so this is what we wanted to show, and we have simplified our solution, and it looks exactly like the one we have. To those who watched the previous video, I did not introduce a like I did today, and I explained that reason. And this one, the guide here is that the guide that we have is that this question said show that. So we already know that our a is not 1. Our a here in this case is minus 2. So we needed to find that a, and we used one of the points that is given in question. We know that when x is 0, y is equals to 8. We used that point and substituted. It helped us. Now we are on the last part. It says determine the value or values of x for which the graph of f is concave down. Now, for concave down, remember we discussed that if you have a cubic polynomial, x cubed plus bx squared plus cx plus d. If you get the first derivative of this, it will give you a quadratic equation. I'm doing this in general, okay? Then plus c plus 0 if you differentiate a constant. Now, if you differentiate it further, second derivative, you will come up with a line. This one is not squared, it's just x. This part, it should just be x, okay? Thanks about that. Now, so we are saying here, we are being asked a question to find concave up. Concave, okay, it says concave down. When we are discussing concave down, we are discussing a graph that looks like this, and where the tangents are above the function. And from our knowledge of quadratic equations, this can only happen if this one, it means maximum turning point. So how do we get a maximum turning point? A maximum turning point is found when the second derivative, for maximum turning point, the second derivative at that point should be less than 0. So we are saying here, f of x that we found is equals to minus 2x cubed plus 12x squared, we found it, minus 18x, then plus 8. We need to find the second derivative here. The first derivative will give us minus 6x squared plus 24x minus 18. That's the first derivative. Then the second derivative gives me 2 comes down, that's minus 12x here plus 24. Now, so we are saying for maximum or for concave down, that means for maximum TP or less than 0. That's what we learned from above here. Now, so this implies that an equal sign here. From the second derivative, it means minus 12x plus 24 should be less than 0. Now we deal with equations the same way we deal with inequalities, or we deal with inequalities the same way we deal with equations, except for one rule. This one, when it crosses, it becomes negative. When you multiply or divide both sides of an inequality by a negative value, you reverse the inequality sign. So at this point, I need to divide both sides by negative 12. So because I'm dividing by a negative, I already reversed the inequality sign. Then here, it simply means that our x should be greater than 2. So if we check with our graph, we check cached, we said that the values of x that are greater than 2. If you check this graph here, x is equals to 2 is this point. Now from this point going this, because we are saying x is greater than 2. So this is the direction of x is greater than 2. Surely it is giving us concave down. And if we are to sketch tangents, they will be above the function, as the notes say. So we have answered these questions. Please pay attention, continuously learn, and subscribe, give your comments and share. Thank you so much.